All right, ladies and gentlemen, it becomes clear to me, or it has become clear to me, that I think it's the distance equals rate times time problems are the ones that we're struggling with the most, okay? And there were not any on this worksheet, and I wanted us to practice that, and I honestly, I gave out the wrong worksheet. I thought there were some on here, and there weren't. So what I'm gonna do is I want us to do 3 of them right now. I'm going to set it up and tell you about the situation. I want to give you about 3 to 6 minutes to try it on your own. I don't want everybody to just sit there going, I have no idea how to do this. But I'd love for you to try to help each other for those 3 to 6 minutes, and then I'll go through it. And we're going to do that 3 times. I've got 3 different problems, okay? None of them are very much really hard or really easy. I mean, they're all just kind of basic problems. So let's start with this first one. First one is, so Taylor and I start 11 miles apart from each other on the trace, and we run towards each other. It takes 30 minutes of running for us to meet, and Taylor runs 20% faster than I do. So how fast is each runner? Okay, and this is, of course, a distance equals rate times time problem. And now what I want you to do to start to notice, I'm going to give you some hints on this first one, is whenever you see a relationship 20% faster, so that's referring to the speed, the rate, okay? That's a really good indicator that that's going to be something to do with your variable. You know, when you have your x times something or x minus something, or maybe 30,000 minus x, you know? And so when there's that relationship, that's kind of pointing you towards what the variable should be. But either way, we have to remember that when you take a distance is literally a rate times a time. So this might be one of those situations where I'm going rate times time plus rate times time, you know, that kind of thing, because I have got to see that as a distance, all right? Okay. Go ahead and pause the video right here. You guys give this one a shot, and in 3 to 6 minutes, we will work it together. All right. Hopefully, I gave you enough hints that this one wasn't too bad. Okay, well, here's how I would do it. First, I'm going to say that I'm going to use W for my speed. Okay, so W is equal to Watkins speed. Okay, well, then you go, well, Taylor runs 20% faster. Well, okay, if I was going 100 miles per hour and she was going 20% faster, that would mean she's doing 120. Now, obviously, we're not running if we were driving or something. So that shows you the relationship there. So I know that I have to multiply mine by 1.2. That's like 120%. She's doing all of what I'm doing, that's 100%, and 20% more. That's the 120%. So that is Taylor's speed, okay, or Taylor's rate. Okay. Now, we've got a time and we've got a distance, a total distance. And so really what we're looking at is we're looking at how much distance I covered. So we go Watkins distance, okay, plus Taylor's distance must equal the total distance, right? I mean, that's how this problem is set up. And so you find my distance by just using rate and time. And so what's my rate? W. What's my time? 30 minutes. Now, there's one thing I want to point out is, you know, we're going to talk about speeds and rates in terms of miles per hour. And so since we're going to talk about miles per hour, I really want to convert that 30 minutes to an hour or 2 hours, and that would be 0.5 hours. It's half an hour, okay? So there's my rate and my time, so that's my distance, plus Taylor's rate, 1.2 W, times her time, 0.5, and all of that must add up to the total distance, 11 miles. And that's the equation. And once you get to there, you go, oh, this is easy. You have 0.5 W plus, let's see, 0.5 times 1.2 is going to be what? 0.6 W is equal to 11, which gives me 1.1 W is equal to 11. Divide both sides by 1.1, and W is equal to 10. 10 miles per hour. That was easy. So Watkins speed is 10 miles per hour, and Taylor's is 12 miles per hour. If you multiply 10 by that 1.2, you get 12. Okay, round 2. Ready? Here we go. Now we're going to talk about motorcycles. Cody's motorcycle goes 50 miles per hour. And let's see here. Cody's motorcycle goes 50 miles per hour. Jake's motorcycle goes 20 miles per hour. Jake gets a 6-hour head start. At what point does Cody pass Jake? Okay. Now, again, you saw me erase something, but you know, this right here is always a hint to our variables. Okay, that's when there's that relationship. That's going to be the relationship to our variables. Now, what I want you to do, though, is I want you to figure out everything. It says at what point. I want to know how long it took time-wise and how many miles it took. So I want you to imagine we walked out on the trace and Jake got on his motorcycle going 20 miles an hour and said, go. And we stood there for 6 hours. And then after 6 hours, we looked at Cody, whose motorcycle does 50. We said, go. And we want to know how many hours does it take? And how far down the trace are they going to be when they pass each other? Okay? All right. Go ahead and pause the video. This one might take a few more minutes. I don't know. But give it a try, and then we'll work it out in just a second. Okay. Hopefully you got this. So now here's the deal. When it doesn't matter fast or slow, if I start here, and I'm going, and I'm going, and I'm going, and I might even be going slow, and then someone else starts here, and they go really fast. When they pass me, the one thing that we have in common is that the distance is the same. At that one instant where they pass me, the distance is the same. So all of a sudden, Cody's distance is the same as Jake's distance. Now, Jake got this 6-hour head start. So if we look at Cody's time by being t and say, well, that's Cody's time, then t plus 6, and I'm multiplying. I'm not saying 6 times as much time. I'm saying 6 hours more. So t plus 6 is going to be Jake's time. Okay? And we know that their distances are equal. So distance is equal to rate times time. Here's a rate, there's a time. Here's a rate, here's a time. And the distances are equal when they pass each other. This one becomes so easy. So we set them equal to each other. So Cody's time is t, and his speed is 50 miles per hour, equals Jake's time is t plus 6, and his speed is 20 miles per hour. We set those two things equal to each other, and we get 50t is equal to 20t plus 120. I can subtract the 20t from both sides and get 30t is equal to 120. Divide by 30, you get t is equal to 4. So what does that mean? Well, that means that Cody's time is 4 hours. Okay, it's important to kind of think about whose is what. So Cody rode for 4 hours, which means Jake rode for how long? Rode for, well, you got to add 6 more, so you get 10 hours. And then the question is, well, how far did they go? Actual miles. Well, if Cody was doing 50 miles an hour, 50 times 4 is 200. And Jake's doing 20 miles an hour times 10 hours, that's 200. So they met 200 miles away. Pretty easy. Okay, all right, last problem. Last problem, here we go. Here's the situation. Katie walks and then runs to Kosciuszko. She walks part of the way and then runs the rest of the way. She walks 4 miles per hour and runs 10 miles per hour. The trip of 20 miles took her 2 hours and 36 minutes. How far did she walk and how far did she run? Okay, so she walks 4 miles per hour. She runs 10 miles per hour. Whole trip took 2 hours and 36 minutes. This might look like an ugly number, but if you think about it, 36 over 60 is the same thing as what? 6 over 10. So that means that's 0.6. We like that. So it converts to a decimal very easily, okay? How far did she walk and how far did she run? Okay, you should be a little bit well practiced on these, thinking distance is equal to rate times time. Distance is equal to rate times time, and then you need total distance. You can do it. So we're going to pause the video, give you guys about 4 or 5 minutes, and then we'll talk about the answers. Okay, let's try this one. I tried to give you a lot of hints on this one, okay? We look and we talk about, this is her total time. That relates her length of time walking and her length of time running, is the two of them must total 2 hours and 36 minutes, which is the same thing as 2.6 hours. Okay, we know, so what we're going to do is we're going to take the distance that she walked plus the distance that she ran would have to equal the total distance, right? That makes sense. So the distance that she walked, rate times time, what's her rate? 4 miles per hour. What's her time? Well, let's say that her time is t. So that'll be time walked. Okay. Well, then what would be her time for running? Time ran. Well, if her total is 2.6 and she spent t of it walking, then 2.6 minus t would be how much she ran. So we have 4 times t, her time walking, plus her rate of running is 10 times her time of running, 2.6 minus t, equals the total distance, 20 miles. Okay, super easy problem. This is our rate times time, which is a distance, plus rate times time, which is a distance, equals our distance. So we get 4t plus 2.6 times 10 is what? 26 minus 10t equals 20. So we combine like terms and you get negative 6t plus 26 equals 20. Simplify, subtract the 26 from both sides, you get negative 6t is equal to negative 6, so therefore t is equal to 1. That's pretty easy. So what does that mean? That means that Katie walked for 1 hour. And she ran for 1.6 hours. Okay? So then, how far did she walk? Well, if she's walking 4 miles an hour and she walked for 1 hour, that would mean she walked 4 miles. And that would mean that she ran, that means she ran 16 miles. All right. Okay, hopefully that makes sense and that works. You guys have a great day.